Hello and welcome to this video where we take a look at how we can plot a spiral hose using Python. So our problem statement is as follows. So we have a spiral hose that has the parameters where x equals 3 cosine of t, y equals 3 sine of t, and z equals 0.4 times t. So the main way that we're going to solve this problem is that we're first going to plot a graph of just the path that this spiral helix is going to follow. So something like this. Now, if we take a closer look at this path, that would look something like this. We would also want this spiral to be in a three-dimensional shape. So the way we can make it that way is that first we're going to try to find the Jacobian of this curve, which will give us the tangent, or also known as the velocity vector of this spiral. And we will also find the normal of this velocity vector, the normal of the tangent. So that would be right here. And we would do that using the Frey-Serre formulas. And again, using the Frey-Serre formula, what we would do is find the binormal of these two normals, and then these two normals would represent the plane on which the circular cross sections of this hose is going to be. So these circles right here. So we would find those. And we would write these in terms of functions. So all of these can be found at any given point on the helical circular path. And yeah, once we have those, we would just basically connect those lines and have our final hose. So let's first take a look at how we're actually going to code the whole helical path first. Okay. So as you can see, I've already imported a bunch of functions right here. So what I have is I've imported numpy as np, I've imported jax, I've imported jax.numpy as jnp, and then we've also configured jax so that it works in 64 bits. Likewise, we've also imported the plotly subplots just so that we can make graphs out of everything that we do. So let's get started. So first thing we need in order to plot this helical path is the coordinate, the time coordinate. So let's call them t equals np dot length space that goes from 0 to 2 pi, 2 times np dot pi, and we would like to have 100 values in between. So basically what this would give us is 100 evenly spaced values from 0 to 2 pi. So that's our time values. After this, we would create a function that would give us the actual circular path that we need. So let's call that def, define the function as curve. And this function would take the input of t, the time as the input, and then we would simply write this as, say, xyz equals numpy np dot array brackets and square brackets. And so our x value, according to our given question, is 3 cosine of t. So we'll just write that down, 3 times cosine of t. Then we have our this would actually be np dot cosine. Just to make things easier for us later on when we'll actually start using jax, I will change all of these to jnp, just because jax numpy doesn't work very well with numpy itself, so we're just gonna have to specify it that way. So we do that, cosine of t, and then we have our y value, which is going to be 3 times np jnp dot sine of t, and then finally we have our z value, which is going to be 0.4 times t. Alright, there we go, and we want our function to return the x, y, and z values. There we go. And once we have the function, we're just going to store this in a variable. Let's call it spiral equals curve, which takes the function t. Right, there we go. And Okay, so it looks like I put a comma instead of a dot, so yeah, that should fix it. All right, there we go. Yeah, now once we have that, let's just plot it out in a graph. So that would be fig equals make underscore subplots. And then we want this figure to be a three-dimensional scatter plot. So I'll do just add underscore scatter 3D. And our parameters are going to be our x value, which is going to be stored in the first column of our spiral variable. So that would be spiral square brackets 0, which means the first column, comma this, and y equals spiral. Again, this is going to be in our second column, so it's going to be 1 comma column. And then our z values are going to be stored in the third column. So that's going to be 2 comma colon. Again, this should be square brackets since it's an array. And then finally, our mode will be lines, since we actually want the path to show up as a line and not a bunch of dots. So let's take a look at it, see what it looks like. All right, there we go. We already have a pretty rudimentary plot of the spiral. So let's change a few things on this graph. First of all, let's change the layout. Fig dot update underscore layout. First of all, let's change the width and length of the graph. So let's go with width at 600 and height at 600 as well. And then our template, let's turn it into dark mode. So plotly underscore dark. Oh, looks like there's an error. Okay, I seem to have missed an alphabet there. All right, there we go. So that's our path. So just to make this spiral a little bit longer, I'll turn this in, I'll extend our t values from 0 to 2 pi to 0 to 4 pi. So let's see how that changes the graph. So yeah, that looks more like a spiral that we want. So from here on out, we're gonna keep adding more stuff to it so that it looks more like a hose that we want it to look like.